All right, we're gonna go ahead and get started. Welcome everyone, another CPTC meeting. Again, meetings are at Tuesdays at 6:30 p.m. And this week we're gonna be, or this meeting, we're gonna go over OWASP top 10, but part 2. If you guys missed, we did OWASP top 10, I think it was two weeks ago, maybe it was 3 weeks ago now. We went over like 3, I believe, of the vulnerabilities in the top 10. I recorded that, it's on UF6's YouTube channel. You guys go check that out. I'll post, at the end of this meeting, I'll post the link to this video, which will be in the same playlist as the other part 1. So you can check it out there. But you don't really have to know, you don't have to know the first video or the first meeting to know this one. They're sort of unrelated in terms of vulnerabilities that we're gonna be talking about. So some things to know, as always, any topics you guys want to learn about this semester or even teach about yourself, put in the Google Sheet, which I'll link in the comments here. Oh, wait, okay, I'll link in the comments later. It's also, I think, in the Slack and the Discord as well. But you guys can put down anything that you guys want to, any like topics in pen testing or red teaming that you guys want to learn about or interested in that you don't think I've covered yet or haven't covered in past meetings. Just throw it on there and I can try to cover it. And similarly, any topics that you think you'd like to maybe do a meeting about yourself, you can also put there and I'll reach out to you so we can figure out a time for you guys to do that. Another thing, I'm sure everyone's done this by now, make sure you guys are joined to the CPTC Discord and Slack. For recordings of last semester's lectures, there's the UFC YouTube channel, which again, I'm going to link at the end of this meeting so you guys can see the playlist of all. I think we have everything from last semester and then also this semester. That's when we started recording them. If you need a Kali VM, which you do not for this, you won't need one for this meeting, but you will need OpenVPN installed. But we did that again at the last OWASP. So if you guys were at that last meeting, you should be fine. If not, we can get you set up pretty easily. But if you do need Kali VM, maybe if you're working on stuff on your own or for future meetings, you can send me a DM. I can help you get you set up with that. And then also make sure you guys have a tryhackme.com account, which we are going to be doing today. So make sure you guys have one of those accounts, and hackthebox.eu. Those are the 2 sites that we use most often in this club. There's no questions, so we'll move on. You guys can hear me okay, right? Do I sound okay? Okay, cool. So we're going to be doing today, continuing learning about OWASP top 10, and then continuing on that same Try Hack Me room, the OWASP top 10 room. So for those who I guess missed the last meeting with the OWASP top 10, I'll just quickly go over what it is. It represents the top 10 most critical and common security vulnerabilities that exist in web applications. And it gets updated every few years to represent like the newest data on the most common vulnerabilities. I think the last time it was updated was like in 2017. So everything from 2017 onward, the vulnerabilities have remained pretty consistent in terms of how common they are and how critical they are. So we have the ones crossed out are the ones we covered in the last meeting, which are injection, broken authentication, and XSS. The 2 that are starred are the ones we're doing today, which is Insecurity Serialization and using components with known vulnerabilities. So we're doing 2 today. Should be a fairly quick meeting. And then I think in future meetings, I'm going to try to basically finish off the rest of them because I want to spend, I guess, more time on, if I try to do them all in one meeting, the meeting would either be way too long or I wouldn't be able to cover as deeply each of the vulnerabilities. So I think this is the best way sort of to do it, where we can sort of split up the meetings and work on a few of the vulnerabilities at each meeting. Yes, today it's going to be on insecurity serialization and using components with known vulnerabilities. So what is insecurity serialization? So it occurs when like untrusted, usually user-provided data is provided to a web app to abuse the logic of that web app, specifically through how that data is processed by the application. That can be pretty vague because using that definition alone, like that would mean like XSS is insecurity serialization, which some people, I guess you can make the argument is, but this is more talking about when data is specifically serialized and deserialized. And what that means is just like any sort of data structure or data object in programming that is changed, aka serialized, to a format that's good for storing and transmitting. And then can be reconstructed by the receiver. And reconstruction is aka being deserialized. And so some examples include like cookies, the Python Pickle library, if everyone's heard of that. and then PHP serialize and deserialize functions. So an insecurity serialization can often lead to remote code execution or denial of service on an application. This is actually one of the lower rated vulnerabilities in the top 10. And the reason for this is although it can be very critical if like actually found and exploited properly, it's one of the harder ones to actually exploit properly, just because of how complex the vulnerability can be at times, especially like in real world web apps. So I guess so does everyone sort of have a clear understanding, I guess, what serializing and deserializing data is? If not, I can quickly explain, I guess, the Python Pickle library. The Pickle library is kind of like, you can provide it like, let me think the best way to put this. You can provide it like, let's say you have an object in Python, right? Like it's just, let's see, a random object here. Like, let's say you have a dog object, and that object has attributes like, what type of dog it is, how big the dog is, what color the dog is, right? Let's say it has those three attributes all in one object. But let's say you want to transmit that object over the internet to another server, right? That can then take that object and do whatever it needs to do with it. The way you would do that, you couldn't just straight up send the object to the server over HTTP, because it's just going to be sending like random data that's just not going to be properly formatted. So what you can do is that you can serialize it using the Python Pickle library. You can serialize that object into basically it's a pickle object, but it's essentially just like just bytes, like string of bytes, and then that can be sent over to the server. The server can then grab that pickle object, deserialize it to get the original object, that which being the dog object. So that's kind of how serialize and deserialization works. It's just like a way to basically to format data structures into easy ways to basically for storing or for transmitting, and then can be easily reconstructed or deserialized later on. Are there any questions on that? Okay. If not, then I'm going to go ahead and hop on to try hacking here. Let me do a new share, just my entire desktop. Okay. Can you guys see the try hack me dashboard right now on my screen?
Yeah.
Okay, awesome. So we're going to go ahead and do OWASP top 10 again. So to find that, if you guys haven't done it before, if you click on learn here, go to all rooms, and then you just do a search here for OWASP top 10, and then it's this one right here. And then these are the ones that we went over at the last meeting, and then scroll to the very bottom here, and these two here are going to be the ones we're going over at this meeting. I'll show it again for people who either missed last meeting or forgot. To get the, you're guys going to need the OVPN file to access the machines for this lab. So you're going to want to go to tryhackme.com/access, and then make sure you guys choose whatever location you're nearest. I'm in Gainesville, so I'm US East regular 1. And then you just want to download the configuration file, which is going to be a .ovpn file. And you're going to need that basically to connect to the remote network that hosts the machines that we're going to be hacking into. The extension is going to be like .ovpn. I think the file name is whatever your tryhackme username is. So does anyone not have, I guess, the OVPN stuff like set up and needs help with that? Okay, cool. So everyone has that set up, then you can go ahead and just start up your OVPN files already. So if you're on Linux, it's going to be just sudo openvpn, then the name of your OVPN file. If you're on Windows, you guys want to make sure you guys have OpenVPN downloaded, and then start that up, and then basically just import the key or the OVPN file and run it from there, and then you should be connected. And then again, make sure you guys always want to have this running while we're doing the box. So just whenever you want to do work on another terminal, you have to do like a new tab. So don't close this or quit this or anything like that. Just leave it open for the remainder of the meeting, and then you can close it once the meeting's over. So here, let's go back to the OWASP. And if anyone has any issues while we're going through this, or like having issues with OpenVPN, anything like that, or try hacking in general, let me know and I'd be happy to help you. So let's start with Severity 8, Insecurity Serialization. So this is sort of a lot of what I had already said, but we'll go over it again just to really make sure it's ingrained. Insecurity Deserialization is a vulnerability which occurs when untrusted data is used to abuse the logic of an application. That's pretty vague. Again, like I was saying before, like cross-site scripting can pretty easily apply to this as well, but cross-site scripting isn't really insecurity serialization. So this person like says specifically, this malicious code leverages a legitimate serialization and deserialization process used by web applications. So this is pretty much like I was saying before. It has low exploitability because it's a pretty case-by-case basis, and it's pretty advanced, and you have to have a really good understanding of the inner workings of the actual web app in order to make it work. But it can also be very dangerous because like it can cause RCE, which is remote code execution, or denial of service attacks. So what's vulnerable? At summary, ultimately, any application stores or fetches data where there are no validations or integrity checks in place for the data queried or obtained. A few examples of applications of this nature are e-commerce sites, forums, APIs, and application runtimes like Tomcat, Jenkins, JBoss, etc. So these are the types of web apps that you can see that are more likely to be vulnerable to insecurity serialization, because a lot of them take in input from potential user data and has to do a lot of serializing and deserialization stuff. So I guess we'll go ahead and go to the first question here. These first questions aren't really related to anything. They're sort of just like random sort of, I guess, trivia type questions to web apps in general. So who developed the Tomcat application? I'll just show you that one because it doesn't really matter. It's just the Apache Software Foundation. A 2-second Google search and show it. So like, who developed the Tomcat application? I tried this one first because like I thought the letters messed up, but it turns out it's just the Apache Software Foundation. They're pretty similar in length, so it had me fooled for a second. But yeah, this is just the answer. And then what type of attack that crashes services can be performed with insecurity serialization? Any attack that causes a crash in the service, regardless of what caused it, is a denial of service. So these questions are pretty straightforward, not really related so much to what we're going to be learning about, but still good to know. So let's go into, and this TryHackMe thankfully explains deserialization pretty well, better than I can. So we'll go through sort of each of the steps just so we have a better understanding. So we'll talk about objects now. So a prominent element of object-oriented programming are obviously made up of two things: state and behavior. Objects allow you to create similar lines of code without having to do the legwork of writing the same lines of code again and again. For example, a lamp would be a good object. Lamps can have different types of bulbs, which this would be their state, and they can either be on or off, which is their behavior. Rather than having to accommodate every type of bulb and whether or not that specific lamp is on or off, you can use methods to simply alter the state and behavior of the lamp. So in this example question they gave us, it says, if a dog was sleeping, this would be a behavior. So like it's similar to how the lamp is on and off. Dog can be sleeping, not sleeping. That's its behavior. An example of a state for a dog would be like perhaps its color or what breed of dog it is. That would be an example of a state of the dog. So any questions sort of like, again, if you guys have taken like any programming class at UF, you guys probably already have a pretty good understanding of what objects are. So if you don't, let me know and I can help try to explain it a little bit better. But if not, then we'll go ahead and move on to the next question then. So this example, okay, so a tourist approaches you in the street asking for directions. They're looking for a local landmark and got lost. Unfortunately, English isn't their strong point, and nor do you speak their dialect either. What do? You draw a map of the route to the landmark because pictures cross language barriers. They're able to find the landmark. You've just serialized some information with a tourist and deserialized it to find the mark. Okay. So serialization is a process of converting objects used in programming into simpler, compatible formatting for transmitting between systems or networks for further processing or storage, kind of like what we had talked about before. Alternatively, deserialization is the opposite of that, basically converting serialized information into their complex form so it can be understood. So in this example here, they say you have a password 123 from a program that needs to be stored in a database on the other system. To travel across the network, the string needs to be put into binary. And then, of course, the password needs to be stored as password 123 and not in its binary form. So once it reaches the database, it is converted or deserialized back into password 123. So we have here just an example, password 123 on the computer. It gets sent as binary across the internet. And then in the database, it gets put back into place, back into password 123. So this is a pretty simple example of serialization and deserialization. So how can we leverage this? Insecurity serialization occurs when data from an untrusted party, such as a hacker, gets executed because there's no filtering or input validation. The system assumes that the data is trustworthy and will execute it no holds barred. So there's another just like question that's not really related to this vulnerability, but I guess still good to know. What is the name of the base 2 formatting that data is sent across the network? And it's binary. Pretty standard stuff. So any questions, I guess, on what, because I think we've pretty much, yeah. So this is basically everybody talked about like what is serialization and deserialization. So if there's any questions, now would probably be the time to ask it before we jump into more of the exploit side of things. Okay, cool. So let's go to the next section, cookies. So for those who don't know what cookies are basically like tokens that are given to computers after, like, the most common example is like once you like log in to a site, it'll assign you a cookie. That way you can like refresh the page and like even close the tab and go back, and you'll still have your same session. You'll have to log in again. That's like pretty much one of the most main purposes of cookies. So that's essentially just so you have a general idea of what a cookie is. It just allows you to basically it keeps your state throughout sessions. So even if you were to close it and open back up again, it still knows that you are you, and you don't have to log in every single time. Websites use cookies to store user behaviors like items in their shopping cart or session IDs. In the web application we're going to exploit, you'll notice cookies store login information like below, which is not good, like username. While plain text credentials is a vulnerability in itself, it is not insecurity serialization, as we have not sent any serialized data to be executed. Cookies are not permanent storage solutions like databases. Some cookies, such as session IDs, will clear when the browser is closed. Others, however, last considerably longer. This is determined by the expiry time that is set on the cookie. So these are some of the attributes of cookies. So we have the actual name of the cookie, its value, whether or not it's secure only. And secure only means if this is set, the cookie can only be set over HTTPS connections, not HTTP. And then you have the expiry date, which is just a timestamp of how long the cookie is valid for. And then you have the path, which is the cookie will only be sent in if the specified URL is within the request. So it only applies to that sort of that URL essentially. So creating cookies can be set in various. This stuff isn't super relevant. This is just how to set a cookie in. This example is in Flask, so it's pretty straightforward. They just set a cookie called registration timestamp to the current date and time. And as you can see, it shows up here. So this is just sort of a general recap of like what a cookie is. So does anyone have any questions about, like, I guess, what cookies are and how they're useful? Okay, cool. So I guess we'll go ahead and answer the questions here. If a cookie had the path attribute, like it says here, of webapp.com/login, what would the URL of that user? What would the URL that the user has to visit be? And it has to be exactly what it says here, webapp.com/login. And then once the acronym for web technology is secure cookies workover, and it's HTTPS, like I said before, the secure only attribute that is set on, that the cookie can only be set over HTTPS connections. These questions are pretty easy, pretty straightforward, so I don't mind just telling you the answers because they're pretty easy. So let's go to the next section here. So this is where we actually get to start up the machine. So we'll go ahead and go back to the first tab here so we can start up the machine. Start machine like that. takes, I think, a minute or so before we can actually see the IP. While that's starting up, if anyone is having any issues with, they try hack me, they can't start up the machine, or they don't have like VPN connection started up, I guess now would be the best time. I can help you out before we actually get started with the actual hacking of this machine. Okay, cool. So I have an IP now. And again, if anyone's having any issues that they can't get the IP or they can't get to the site, let me know. Here we got the IP, so let's go ahead and just do what they say, and we'll go to the website there. So we get a cool little site like this, and then it tells us to create an account. So we'll go click on Exchange today. Create account. Let's do John, and then blah for the password. Sign up there. Cool. So now we're logged in. Now it tells us to do inspect elements, so we can take a look at the cookies that we have. So right click, inspect element, and then we'll go to storage. I'm using Firefox, by the way. Chrome is pretty similar, but I think the actual this developer bar here is a little bit different. So its storage is somewhere on it. I'm not exactly sure where, but if you have trouble finding it, just let me know. So we got storage here, and then we can see the cookies that were set here. We have password, blah, username, John. Cookies should definitely not, passwords or credentials should definitely not be set in cookies. That's really bad. We also have a user type here, which is pretty interesting. And this is the session ID. So the session ID, this is basically what allows us to like close the tab, open back up again, and still be logged in and stuff like that. I can actually probably try it here if this site's set up properly. Here, let me actually move this out of the way. Great. So if oh wait, it's in the way again. All right. So if I close this and then go back to it again, go back. Oh wait, did it log me out? Okay, no, it didn't. I'm back on it. So yeah, it's because I had the session cookie on it. If I go back here, if I were to delete this session cookie here, then I'd have to log back in. That's what that's for. And then this is the registration timestamp. This is probably useful for like expiry dates and stuff. So yeah, these are sort of the cookies you guys are seeing here. Let's go to what it's saying next. You'll see here that your cookies are both plain text encoded and base64 encoded. The first flag we found one of those cookies. Okay, yeah, so you'll notice here that all of these are plain text except for the session ID. If we double click on that, you can see it ends in 2 equal signs. This is a pretty common way to know that means that this string is base64 encoded. So what we can do is actually just copy this and then look up base64 decode. We'll go to this site here, and then we'll paste it in to decode it. We get a lot of garbage here because this is like an object, but you will also see here a little plain text here, which is, looks like a flag to me. So this is the first flag for the question here. And that's how, yeah, that's how you get the first flag. And then there's another flag here, and they say there's also a user type in the cookie, like we had seen already, user type here. And then which means we're currently a user, and that's confirmed by information on the My Profile page. What if we need to change it to admin? So it's saying to try to change it to admin and refresh, see what happens. So I'll give you guys like a couple minutes to sort of try to work on that one yourself. Pretty much tells you what to do, so it shouldn't take like that much time, but I'll give you 2 minutes. If you guys having any sort of issues, just let me know.
How do you get to see the cookies on Chrome? Do you need an extension?
No, you shouldn't need an extension. Let me actually check on my laptop. So I use Chrome on my laptop. Inspect. Let's see. Okay, yeah. So if you go to when you go to inspect on the top bar, it says application. If you click on that, and then there's a cookies thing, and then you should see it there on the left-hand side. It says cookies.
I see.
Yeah.
Gotcha.
Okay, so we'll go ahead and get the second flag here. So it says if we were to change our user type to admin and then do a refresh, and now it says we're on the admin dashboard, and now we got the flag here. So we can just copy that over, and then that's the flag for the second one. Now this is actually a surprisingly common vulnerability you'll see in like web apps and stuff. Is people who like will store like states, like very sensitive states, in a cookie that's like changeable by the user, which really isn't good because like example here exactly is like if they had like separate users and they also had admins, and you're setting like what they are based off a cookie that can be changed by the user, then basically any user can make themselves admin. Another sort of similar thing to this would be like if you had one here that's called like user ID, and then let's say it had like some like number, like let's say your number 18, right? So your user number 18 in this website, and that's how it knew who you were. But let's say you changed this yourself to like user 19, and then you had entered and you refreshed, and then in a lot of cases, if they're not properly validating it, you would then be logged in as whoever user 19 is. So it could be like Bob or some random guy. That's another pretty common way that people that web apps sort of mess up in the security, and that can be pretty common to find in sort of web apps like that. So any questions on sort of how we did these two, how we got these two flags, or sort of what cookies are, how they're vulnerable in certain ways if mishandled? So this policy by default is supposed to be unchangeable. So they're supposed to be, so these ones here, like session ID, for example, and even like registration timestamp, these like none of the cookies you're not really supposed to be editing cookies, right? Like a normal user wouldn't change their cookies. It doesn't really make any sense. But so in that sense, they're not supposed to be changeable. But the web app needs to have restrictions in place so that if someone like us who wants to edit our cookies can, that it doesn't actually affect the security of the web app. So in that sense, like user ID would not be stored as a cookie at all. It would be stored like in the SQL database on the server, and we would not be able to change it because we wouldn't even have the option to change it. Like this just would not exist for us. It wouldn't show up for us. Neither would password, neither would username. Those things. So yes, they should not be changeable, but they also just shouldn't be cookies at all. They should be just stored like on a database far away from any user's hands to change. Yeah. Okay, cool. So let's go ahead and go to the next section here, which is going to be code execution now. So first, change the value of the user type cookie from admin to user and return to my profile. So I'll change this actually. User type and then user and my profile. Okay. So we did that. Then click on exchange your VM. Okay, exchange your Vim, sorry. Once you've done this, then click on provide your feedback. Okay, we have a nice little provide feedback thing here. What makes this form vulnerable? If a user was to enter their feedback, the data will get encoded and sent to the Flask application, presumably for storage in the database, for example. However, the application assumes that any data encoded in it is trustworthy. But we're hackers, you can only trust as far as you can. So this is sort of what the code on the backend server is looking like for this web app. It takes in a cookie here. It then does, it's using the Python Pickle library like I was talking about before to get a dump of the cookie. It's then basically for encoding it and then setting that as our cookie. So this is sort of how it's setting the cookie. When it asks us to click exchange your Vim, it was doing this right here. It was creating a cookie and then making a pickle of it and then basically for encoding it and then setting it as a cookie. So yeah, and basically what it's saying here, when you visit exchange your Vim URL, a cookie is encoded and stored within your browser, perfect for us to modify. Once you visit the feedback form, the value of the cookie is decoded and then deserialized. And then we can see here that the cookie is then retrieved and then it's basically for decoded and then there's a pickle.loads here. So, and then this is vulnerability exploits Python Pickle. So Python Pickle, if you can find a vulnerability in the pickle.loads and you can provide it like any sort of pickle object that you want, you can provide it like command execution. So you basically have like complete command execution on the box if you're able to provide user input to a pickle.loads, which is exactly what we're able to do, right? Because it's just the cookie here is we're able to change it because it's literally on our browser. Like we can change it to whatever we want it to be. So that's essentially what the vulnerability is in this application. And the reason why, like I was saying before, why deserialization vulnerabilities are kind of hard to find is because like this lab gave us this backend code, right? But we wouldn't normally have this in an actual like pen test. We wouldn't know that it's doing this. So we'd have to make a lot of assumptions in order to get sort of what we're looking for, which is why deserialization vulnerabilities are a lot harder to find because we don't know everything's going on in the back end. So let's do the exploit then. So we're gonna go ahead and start up a netcat listener. So I'm gonna go ahead and tab here and just do nc-lvmp 04444. I'm just gonna leave that running for the remainder of the time. And then we're going to go ahead and get the code that they're referencing here. And then I'll run through what this code does. So here, first, I'm just going to copy it over to my own stuff here. So I'll open up a new tab. Go to OWASP 10. And I'll go ahead and paste it. So what this code does, go back here. What this code is doing, right? This is Python code, so it's importing the libraries that we need: pickle, sys, base64. It's setting the command string to the string rm temp f make FIFO cat. We don't worry about this stuff right now. Or any of this. This is the only thing that matters right here. Just this code right here. And what this is doing is it's executing a bash shell on Linux, and it's redirecting like standard in, standard out, and standard error, all to our netcat pipe to a netcat connection that's connecting back to our IP address that we're listening on, which is going to be right here while we're listening for it. So all we have to do is change this to our IP, or it's going to be your specific IP. It's not going to be the same as mine. So to find that out, I'm going to put another tab and do ifconfig, and then it's going to probably start with like a 10 dot something. So mine's 10.6 to 25.4. I'm going to copy this, go back to the code here, and I'm going to go ahead and change this to my IP. All right, so then this is what the command string is. It's doing basically connecting back to my IP to give me a full functioning shell on the computer. And so that's being stored in a string called command. And then they're creating a Python object called RCE. They're importing OS and then doing os.system command, which can basically execute this string. And so then they're creating a pickle dump, or they're basically converting this RCE object, this entire object here, into a pickle data type. And then they're base64 encoding it here. And then it's going to print it to the screen, so then we can copy it and replace it as our cookie. So it's basically doing exactly what the opposite of this code here in this picture is doing, where this is getting our cookie, and then it's base64 decoding it and then loading the pickle. Here we're loading the pickle, base64 encoding it. That way it can be decoded by this and then loaded by the pickle on the server and then executed essentially. So is anyone confused by that or have any questions? I know that part could be a bit confusing. Okay, so if not, we're gonna go ahead and save this file. And then we can go ahead and run it actually. So Python 3, c2.py. And then you see it prints out some base64. We want everything between the quotes because that's just saying that's in byte format. So we're just going to copy this. And then it tells us to do what? Yep, pasting all that like we just did. Executing it and then copy paste this into our cookie called encoded payload. So let's, here it is. See, now I've got a new cookie here called encoded payload. It's currently set to this value here, which we can actually go ahead and see what it is. Let's basically forward decode it and see what we got. I imagine it's gonna be garbage because it's pickle format. Yeah, see, it's in pickle.
Did you say that these are new? That was a new cookie or something?
Yeah, this is a new cookie that we got because when we go back to, if we go back to my profile here, when you click exchange your VM, when you click this button right here, it sets this new cookie for you called encoded payload.
Okay.
So you should be able to see it after you click this. You might have to like sort of like tab out and then tab back in or refresh to see it. And you should see a new cookie here called encoded payload.
Okay, cool.
Yeah. So yeah, let's go ahead and replace whatever they set it as with our malicious base64, which we got from our Python script. Do a copy. And then we'll just do Control V here. Hit enter. And make sure you guys have the listener running. And then all we're going to do is simply refresh this page. And you see it's hanging on it, which is actually a good sign. If I go back here, you see my listener received a connection. I do who am I? I now have a shell on that that box on that web server that's running. So I'm now remotely controlling that that web app, and we have successfully exploited the server and hacked this box. So I can do like ls and see everything that's going on here. Is anyone not at this point? I can help you get to this point. Okay, cool. So again, if you guys are having trouble with any part of this this process of hacking this box, let me know. I know I can talk a little fast sometimes. So if I said anything that you guys missed or you're stuck on a part, just let me know. I can help you hopefully get through it. So cool. We now hacked this box. What's it asking for now? We got a connection. It's asking us to get the flag.txt. So it's not in this directory here. So let's cd out of that. And then here we go, we got a flag. So just do flag.txt. And now we have the flag and we can just throw it into there. Awesome. So does anyone have any questions or is stuck on any part of this at all? I'll be very happy to help get you through this part.
I'm not stuck. I'm just a little bit behind. That's all.
Okay, cool. Yeah, let me know if you do get stuck at any point.
All right, thanks.
Cool. So this is, this is everything on insecure deserialization, essentially. So you guys have a pretty good introductory to sort of what it is, how it works, how it can be exploited, why it's difficult to exploit, and all that good stuff. Another common and more complex serialization vulnerability you'll see is related to like PHP deserialization. And that one gets a little hard because you can't really do direct command execution like you can do with like Python Pickle. You have to do a bit more complicated stuff to like change variables in the code that can then hopefully get you either get you command execution, which again is unlikely, or at the very least get you more access than your current user account has, such as getting admin. So that's something that like I encourage you guys to look more into. If you just Google like PHP deserialization vulnerabilities, there's like a lot of documentation on sort of how it works and stuff. And it's pretty cool stuff because it lets you like, if you have like let's say on the web, on the back end of the web app, you have like an attribute called like user type, for example, like in this web app. And this is like user type, user or admin. If there's a PHP deserialization vulnerability, you can potentially upload PHP serialized code that will then change the user type back to admin. You won't be able to do like command execution with PHP deserialization in most cases, but what you can do, which is very powerful, is changing variable values, such as the user type, so you can get more access. That's the sort of more complex but pretty cool serialization vulnerability. Okay, so if there's no other questions on serialization or deserialization, I'll go on to the next vulnerability, which is kind of the flipped version of the other one, and that this is probably one of the easiest vulnerabilities that you can really sort of, it's first of all, it's one of the more common ones, and it's also one of the most easy to exploit. So it's kind of like the opposite of insecurity serialization, and that is using components with known vulnerabilities. So this is a very common vulnerability in web applications and infrastructures, and probably one of the easiest to exploit as well. It occurs when any component of web application is outdated and is running a version of the component that is a known and well-documented vulnerability. So simply put, it's just a specific component of the web app that's just outdated and unpatched. And then that specific version has a very well-documented vulnerability. And then with well-documented vulnerabilities often comes exploit code that one can use easily to exploit that vulnerability in that component. And one of the most common places to find exploit code for known vulnerabilities is a site called exploit-db. So let's go ahead and take a look at that. So exploit-db is an exploit database where basically like pen testers, red teamers, actual hackers in the real world will upload their exploit code to this. And then it's basically like, it's kind of like GitHub, but for exploit code. So like we can just even see what's going on here. So Zencart remote code execution, if we click on this, and we've got exploit code for this specific software, whatever Zencart 1.5.7b is. So exploit-db is a very useful website that you will no doubt be using a lot if you continue doing pen testing or red teaming. So let's go. Are there any questions, I guess, on sort of what we're looking at here and why this is like a vulnerability? This is sort of a broad umbrella vulnerability, because we're not talking about a specific vulnerability. We're just talking about the general vulnerability of using components that have vulnerabilities. So it's sort of a vague, sort of abstract umbrella term for any outdated sort of software in your web app. So if there's not any questions, then we'll go ahead and do these, the try hack me for it. So occasionally you may find that the company/entity that you're pen testing is using a program that already has a well-documented vulnerability. For example, let's say that a company hasn't updated the version of WordPress for a few years, and using a tool such as WP Scan, which stands for WordPress Scan. Basically, you can scan a WordPress site for any known vulnerabilities in that specific version. So using a tool such as WP Scan, you find that it's version 4.6. Some quick research will reveal that WordPress 4.6 is vulnerable to an unauthenticated remote code execution exploit. And even better, you can find exploit already made on exploit DB. And then as you can see, this would be quite devastating because it requires very little work on the part of the attackers, as oftentimes since the vulnerability is already well known. And someone else already made the exploit for the vulnerability. So the situation becomes even worse when you realize that it's really quite easy for this to happen. If a company misses a single update for a program they use, they could be vulnerable to any number of attacks. So that's why it's such a high rating on the OWASP, because of how common it is and how easy it is for it to be exploited. Because like it doesn't require like you to actually necessarily do much work other than just pull the code that's already exists, the exploit code that already exists, and basically just run it against the web app. It might require a few changes to the exploit code that you have to do to get it to work for your specific scenario. But other than that, it's a lot easier than like basically most of the other vulnerabilities on this OWASP top 10. So any, I guess, questions on sort of what exploit DB is, why it's this vulnerability is so widespread and easy to use? Okay, cool. So let's go to the next part then. So recall that since it's about known vulnerabilities, most of the work has already been done for us. Our main job is to find out the information of the software and research it until we can find an exploit. So here's an example of a web app that's running Nostromo 1.9.6. When you're like when you're pen testing a web app, the first thing you're looking for is version information of the software it's running, right? You want to know, like, I guess, what software is running, and also what version it is. So the two main things you care about, because you have those two things, you can basically then start Googling online and finding if there's any related vulnerabilities or exploits that exist in that software with that specific version. Thankfully, this example here, it literally just tells you on the default page. It tells you it's the Nostromo is the software it's running, and 1.9.6 is that version that it's running. So it just tells you right up there. A lot of times it can be a little bit more difficult. Sometimes it'll either be like you'd have to check the HTML source code, and it might be like in a comment somewhere. Other times it won't be anywhere, and you have to do some fingerprinting to figure out the version, which gets a little bit more complicated. But the main thing you care about is finding what service is running on the web app and what version it's running. And then from there, you can basically try to find if it's an outdated version, if there's any vulnerabilities, et cetera, et cetera. So now that we have the version number and the software name, we can use exploit DB and try to find some exploit code for it. And you can see there's multiple here that show up: Nostromo 1.9.6, remote code execution. The top result has to be an exploit script. So like I was saying before, it may not work the first time. So it helps to have a sort of understanding of whatever programming language it's written in, so you can fix any sort of bugs that are in it, or maybe alter the code a bit so it works for your specific case. I think in this case, they just had an uncommented code that needed to be commented, and then it worked for them. Yeah, so like I was saying before, it's also worth noting that it may not always be this easy. Sometimes you'll just be given a version number, like in this case, but other times you may need to dig through the HTML source or even take a lucky guess on an exploit script. But realistically, if it is a known vulnerability, there's probably a way to discover what version the application is running. And that's really it when it comes to that sort of what this vulnerability does. So let's go ahead and do the lab. So we'll go ahead. I'm going to terminate my old machine because we're not using that one anymore. And then we're going to go ahead and start up this guy. And while that's starting up, again, if anyone has any questions or if they're having any issues with Try Hack Me or any questions at all related to what we're doing, let me know.
Alright, so I'm still on the previous one and I
Mhm.
got the Python script and I'm trying to put the encoded message in the encoded command in the payload.
Yeah.
And the page hangs, but I never get anything on my endcat.
Okay, so let's take a look here. So your Python file looks like this, and then you just change the IP to your IP.
Yeah, the one on the try hack me.
Okay, so this IP
address.
isn't going to be the try hack me box. It's going to be your IP. So if you go to like, are you on Linux or on Windows?
I'm on Linux.
Okay, cool. So if you just open up a new tab and do like IP space A, and then do you see an IP that has like 10.6.25 or not, like 10.6 that's something, or 10 dot something, like it starts with a 10?
No, I do not. Maybe it's something to do with, I'm using the Windows Linux subsystem.
Oh, okay. And you're running OpenVPN on the are you in like
On
the GUI
Windows.
version on Windows? Okay, that's probably the reason why.
Yes.
So to fix that, does PowerShell have Netcat? Like you can open like a PowerShell terminal and then try to run like nc-h. No. Let me think. Are you able to run OpenVPN on the Windows subsystem?
I think I tried doing that last time, but I was
I
running
was
into
having
trouble.
issues. Okay, let's. I think there's a pretty easy way to get Netcat for Windows. Yeah, download. Where's Windows? Microsoft Windows binaries. Linux computer sources. Because I'm pretty sure there's a. Oh, okay, wait, this actually might work. Okay. Okay, yeah, this is one you want. So here, I'll put this link in the chat. If you go to this and then download like the nc.exe from it, and then use that in PowerShell, that should work. And then for the IP that you want to put, you want to open up PowerShell and do IP config/all, I believe. And then you want to do the whatever IP I think starts with 10 dot whatever it is.
Okay.
Yeah. Yeah, because I think Windows subsystem for Linux and like the VPN stuff, they sort of don't mix well together. But that should work once you have that. And then yeah, let me know if you're still having issues.
Okay, thanks.
No problem. So is anyone else stuck on the last part for the known vulnerabilities? Was anyone able to find the vulnerability that existed for that application? Let's go check out the actual app. So actually, let me. No, oops. Close this. Okay. So we go to the site here that they gave us, and it has like a nice little CSE bookstore web app they have going on here. Books, publisher, pretty cool stuff. There's an admin login, which is nice. And then Basically, the following is a vulnerable application. All information you need to exploit it can be found online. Note, when you find the exploit, you pull all your input in quotes, for example, ID. Okay. So was anyone able to find what software is running on this web app, and specifically what version is running on this? If you did, if you want to put it in the chat or speak up, whatever you want to do. If not, I'll give you guys a few more minutes to work on it. All right, so I'll go ahead and show the first part here. So the software that's running here, some key things you can look at is sort of like the bottom here. It gives us some information. So just something called project worlds, and then it redirects to a project worlds.in. This is a pretty likely meaning that like this site is using the project worlds service for basically to run this web app. So we basically have found the service now that this is running, project worlds. Now something we want to look for is the version. So let's go to like view page source here to look at the HTML to see if we can find anything related to the version. So we can do like look for project worlds. Okay, so nothing related to the version number that this is running. That's okay because we can still do some Googling here and see if we can find anything any exploits related to project worlds. So if we do project worlds, and then let's actually search on exploit.db. Let's do that first. Let's go to exploit.db. And then we'll do search here for projects world. Oh, I definitely spelled that wrong. Is it project world? Wait, what's it called again? Project worlds. Project worlds. Oh, okay. So it doesn't immediately show up on exploit.db. That's okay. Then we'll just do some Googling. So we'll do project worlds, and then we'll just Google exploit, and you can see we have some ones here, some exploit.db related ones. I'm not sure why. I guess exploit.db's like search engine isn't very good. I always prefer to use Google anyway. So we have here some exploits. We've got online bookstore 1.0. We have gym management system. We already know that this, like, just based off the look of it, that this is not a gym management system. This is most likely the bookstore because, you know, it's a bookstore. I like to see bookstore on exploit DB. Oh, okay, cool. Let's go to that then. Let's go to exploit DB and let's see what CSE bookstore gives us. Oh, awesome. Okay, so we have like, oh, oops, I definitely misspelled something again. Yep. Bookstore. Okay, cool. So we have some multiple SQL injection, authentication bypasses, cross-site scripting. This is all pretty interesting stuff. And most likely is relevant to what we want. But let's see if we can find something that's a bit even like more critical than just an SQL injection or cross-site scripting or authentication bypass. RCE is sort of the most critical you can get. So if we go to Project World's exploit again, like I said before, we know it's not a gym management system because it's obviously a bookstore. But we have here online bookstore 1.0 on exploit DB. And then it's unauthenticated remote code execution. This is sort of like the mother of all vulnerabilities, right? If you, this is like, there's basically nothing more severe than an unauthenticated remote code execution, essentially. Because obviously unauthenticated meaning you don't even have to log in to the server. You don't have to have any sort of like credentials or anything. And then remote code execution, meaning you can basically get a shell on the server that's running it, which basically means you have almost full control of whatever's on that server, given your user that you get it as. So this is pretty interesting here. So we've got some Python code here. Let's go ahead and download this exploit code just by clicking the download button there. Go ahead and save the file. And then we'll open up our terminal here. And then I'm going to move it to my relevant directory because I like to keep sort of organized my try hacking stuff, but you can do it directly from downloads, up to you. Just going to move it real quick to here. Okay, and then I'm going to go ahead and open this up to sort of take a look at it. So we can try to understand it a bit here. So let's take a look at this code. I haven't looked at this before myself, so I don't have a full understanding of what we have going on here. But just based off the description, unauthenticated remote code execution, doesn't give us much else. But here, let's see. So it's importing some libraries, obviously. Then it takes in an argument, which is going to be the URL. So that's going to be the URL of our vulnerable site, which is going to be this guy here. And then it does, okay, it generates a random file name, it looks like, out of 10. Then the payload is PHP payload. So this is seems like it's going to be a PHP file upload vulnerability. So what that means that they're basically, I think, going to generate a PHP file that will then get uploaded to the server. And then once you run it, it'll get executed. And what this PHP does is that it basically accepts any sort of command from the URL query parameter called CMD, and then there's a shell exec on it. And in Python, shell exec means like run as terminal command. So this is going to allow us to basically have a full shell on the box. Let's see, does file, it calls it an image, but then it actually uploads it .php. So yeah, attempt to upload PHP web shell. So it seems like it's uploading a PHP shell that the website thinks is an image. So like a lot of websites will allow you to upload like, you know, images. Like let's say you have like you need like a profile picture, for example. It obviously requires you to upload like a PNG or a JPEG or something. But in some cases, if they're not validating properly, you can actually upload like PHP code instead. And then if they accept it, that PHP code will then get run, and then we can get something like remote code execution. So I think that's sort of the idea of what's happening here, is that we're uploading it to Bootstrap IMG. And then once it gets uploaded, then we're basically just making requests to that PHP with CMD being our command. And then we basically have a shell. So this exploit is pretty straightforward. It's just a vulnerability that allows us to upload The website allows you to upload images, right? But it's not validating properly, so we can actually upload malicious PHP code, and that code then gets executed. And then that code that was being is going to be this is going to allow us to run system commands on that box. So let's go ahead and give it a run. Let's do -H to see the help page. So usage, give it the URL of the target. So we're just going to give it the URL, which is going to be this guy here. I'll remove this. Hit enter. Attempting verifying shell upload web shell it was uploaded to see bootstrap img random string file name .php. Example usage. Okay. Do you wish to launch a shell? Yes. And look at that. We have a shell. We can do who am I? We do ls, and now we have a remote shell on that web box, and we've basically successfully fully hacked this machine. So we can dig around to see stuff that we can find and stuff like that. So does anyone have any questions on sort of how we did this, why it works, exploit DB in general, finding the version, anything like that?
So is a common thing to do just running like pre-made scripts, like aside from obviously putting in your your IP address to get into like these websites, I guess? Like I don't understand how simply running a script can push yourself into a shell.
Yeah, so it is a pretty common thing. Again, I would always say before you run it, always check the code, because you're running code on your computer that comes from the internet. It's always good to check. But the reason this works is that because this person here, this author, Tiberius, he spent time, he found the vulnerability in this website, right? And then he wrote exploit code to exploit it. And that's where he wrote it here. And then he made it freely available for people to use. So that's essentially why this was able to work. We were able to essentially just download a script from the internet, run it against this URL, and then we got a shell. Is because Tiberius, he is the one who actually put in the work to get this exploit to work. And we're basically just using his exploit on other websites that have the same vulnerability that he found to be able to get a shell. That's why this vulnerability is sort of one of not only the most common, but also one of the easiest, because it requires very little work from us. We just have to download exploit scripts that other people have already worked on and then use it, which is why this is sort of a very, very easy way of exploiting machines if the exploit code actually does exist online. Does that make sense?
Okay. Yeah, it does.
Yeah. Cool. And there's actually I was planning actually going on at our next meeting, going over essentially how this exploit works, not this one specifically, but sort of how this category of exploits, which is something called LFI, which is local file inclusion, was something I was planning on looking into next. So I'll probably do that at the next meeting, both LFI and RFI, which is local file inclusion vulnerabilities and remote file inclusion vulnerabilities. And they kind of play into this sort of what this exploit is, pretty similar. So yeah, does anyone have, I guess, any other questions related to sort of how we exploited this and why? Actually, we could probably just get the flag, right? So to get the flag, it's asking us how many characters are in etc past WD. The command is just wc-c etc past WD, and the answer is 1,611. If anyone's stuck at a certain point, either from this this box or the previous box, let me know and I'll be happy to help. Or if anyone has any sort of general questions about anything we learned today, let me know. Okay, so if not, then next week, probably gonna take a look at local file inclusion. I'm not actually, it might be either next week or the week after, because I know there's midterms and stuff. So I don't know if I'll be able to do it next week. But if it's next week, then it'll be next week. If not, it'll be the week after, and we'll be going over probably local file inclusion and remote file inclusion vulnerabilities. And again, just to reiterate, any topics in pen testing or red teaming you guys want to learn about or teach about yourself, feel free to upload it to the Google Doc, which I'll put in the Slack and the Discord. But yeah, I'll stick around for if anyone has any other questions or if they're stuck on anything. But other than that, the meeting's pretty much over, and I'll see you guys at the next meeting.